going on, guys? Let's do this problem right here. Here this question is asking for this picture must be designed for an input impedance of greater than 10 kilo ohm and a transconductance GM of at least 1 over 260 ohm. If beta is equal to 100 and IS is equal to 2 times 10 to the power of minus 17 ampere and VA is equal to infinity, determine the minimum allowance values of R1 and R2. Here the question is asking us to find out the minimum allowance of R1 and R2, and we have the impedance, input impedance of greater than 10 kilo ohm, and we have all these values. Okay, the first thing is let's note down the given things. Here we have transconductance that's given 1 over 260 ohm, or you can say Siemens. Both of them are same thing. Then and also we have the saturation current IS, that is 2 times 10 to the power of minus 17 ampere, and VA is equal to infinity, beta is equal to 100. First we can solve for the IC. IC is GM, transconductance, times VT. Now the transconductance given to be 1 over 260 Siemens, 1 over 260 Siemens, and VT is the constant value, that's always 26 millivoltage, and that gives us, this is Siemens millivoltage, that gives us 100 microampere. This is our IC current. Now the next thing is we are going to find out the VBE voltage. VBE is equivalent to VT ln of IC over IS. We have all the information. VT is a constant value, that's 26 millivoltage. Ln of IC is 100 microampere, and IS is 2 times 10 to the power of minus 17 ampere, and that gives us 760 millivoltage. And also we can calculate IB. IB is IC over beta. We already found out IC, that is 100 microampere. 100 microampere divided by beta, that is 100 divided by 100, and that gives us 1 microampere. And we can calculate R5. R5 is equivalent to beta divided by transconductance. Beta is 100 and the transconductance is 1 over 260 Siemens, and that gives us 26 kilo ohm. Okay, and also here we are trying to find we want to find R1 and R2. Let's create a relationship between R1 and R2. R1 is equivalent to VCC minus VBE divided by IB plus VBE divided by 2. We know the VCC value, that's 2.5, and VBE we calculated right here, 760 millivolt. IB we calculated here 1 microampere plus VBE divided by, this one is R2. VBE is 760 millivolt divided by R2. Now here in the initial condition they have mentioned the impedance should be greater than 10 kilo ohm. Let's put that one right here. R input should be greater than 10 kilo ohm, and R input is nothing but R1 parallel, R2 parallel, R5, and that is R input, that should be greater than 10 kilo ohm. Now instead of this is R1, we can plug this value, because if we plug this one, we can make everything into one unknown variable, because we already know R5. We solve for R5 right here. We have R5, but we don't have R1. But we have made a relationship between R1 and R2 here, this one. So if we plug this one instead of R1, we can solve for R2, because we have R5 available, 10 kilo ohm, and R2 is the only unknown constant, so we can solve for R2. So let's go ahead and plug this one right here. Instead of R1, I write the whole thing. 25 voltage, actually 2.5 voltage minus 760, this one 760 millivoltage divided by 1 microampere plus 760 millivoltage divided by R2, and that one parallel to R2 parallel to R5 should be greater than 10 kilo ohm. Okay, let's continue here. Let's get rid of these things. Here what we are going to do, we just have to solve for R2, then we can solve for R1. Okay, so parallel mean we can write the whole thing as 1 over this whole thing, because parallel mean it's similar to 1 over these things. 1 over 2.5 voltage minus 760 millivoltage divided by 1 microampere plus 760 millivoltage divided by R2. Parallel mean plus parallel mean this also 1 over R2 and this one 1 over R5, and that is greater than 10 kilo ohm. Now R5 we already found out. I erased it one. Oh, it's already here. It's 26 kilo ohm. So instead of R5 I directly put it 26 kilo ohm. And here the next thing is we just have to rearrange this whole thing and solve for R2. And if you solve for R2, you will end up with R2 is greater than 23.57 kilo ohm. In the same manner, we have to solve for R1 as well, because here the question is asking for R1 and R2. We just solve for R2. Now to solve for R1, we are going to bring the same thing, but in this time we are going to write it as R1 parallel R2 parallel R5 greater than 10 kilo ohm. Now we know R2 and we just have to solve for R1, so we can just keep it in this same way and solve for R1. Now if I write the equation as this one, this is going to be 1 over R1 plus 1 over R2. Instead of this R2 I put 23.57 kilo ohm plus 1 over R5. Instead of R5 I put 26 kilo ohm. That should be greater than 10 kilo ohm. Now we have to just rearrange and solve for R1, and if you solve for R1, that will give us 52.32 kilo ohm. And these are the R1 R2 values we have to have in order to keep this impedance input greater than 10 kilo ohm. And that's how we do this kind of problems. I hope you guys find this video helpful. Thanks for watching, and if you are trying to learn electronics too, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.